We have 5.5 completing the squares. So let's take a look here at completing the squares. This is a way to factor a quadratic and solve a quadratic without numbers that are factorable. So in 5.2 we talked about factoring. We looked at numbers that multiply to give you something, that also add to give you the middle x value there. I mean, those are the items that we talked about, but when it boils down to it, you probably realize is that you can't always factor something to solve a quadratic. So what we're going to do is we're going to figure out ways to rewrite them so that they are factorable. So how do you complete the squares? Well, here's a little mini formula for you for completing the squares. It's called b over 2 squared. Very simple. B over 2 squared. Right? You can say it really quick. B over 2 squared. B over 2 squared. Right? It's a really small, quick little formula, but it's how you use that formula that will help you complete the squares. So basically, here's what you're supposed to do. You have an ax squared plus a bx plus a c, but what we're going to do is when you complete the squares, you take whatever the item, the b is, and you add that to one side, which is right here, and you also need to add it to the other. So what you're doing is you're taking whatever that term is and you are squaring it and adding it to both sides to solve it. Alright, so all we're going to do with example 1 is find C. That's all that I'm really concerned with. That's all that I'm really interested in. So let's see if we can find C. So to find C in this one, what you need to do is you need to find your B, and your B happens to be negative 7. So we remember our formula, which is B over 2 squared. So where you have to figure what that factor is. So to do that, I take whatever my B is, which is negative 7, and I plug it in. So I have negative 7 over 2. Well, what you do is you take that squared through to both items. So negative 7 squared is 49 and 2 squared is 4. So that's what C is. I just found what C is. So when you go to factor this is actually pretty simple. This is your factor. So basically what you get is x minus, because it's a negative, 7 halves squared. That is your factor that you end up getting. So you do all this work to find your factor, and that factor is this item right here. And then when you complete the squares, thus the term squared, that item is squared.
Snapple, made from the best stuff on earth.
Taking a look at example 2 now. To complete the squares, this can't be factored. And we know that we gotta use completing the squares not only because it's obviously the section title named completing the squares, but because can you think of two numbers that multiply to give you a negative 3 that add to give you 10? No. So first we gotta get all the x's onto one side. So what I'm gonna do is I'm gonna add 3 to both sides to get those gone. And now I leave a little opening there. So according to the formula is b over 2 squared. So b is 10, so that's like saying 10 over 2 squared. Well, 10 divided by 2 is 5. So it's 5 squared, which is 25. That 25 I need to add to this side and this side. So I put a 25 over here and a 25 over there. So when I put those together, I end up getting a 28. And this I need to factor. So this isn't hard to factor because it's just like the last problem. This 5, whatever's inside the parentheses when you simplify, that is your factor. So what I mean by that is you put in parentheses an x, right? That's the factor. You put a parentheses, then the x, and then whatever that is, it's a positive 5, so it's x plus 5 because it's a positive 5 squared. And that equals 25, or 28. Now you can solve it because now you can do what we did in 5.3. Now you could square root both sides to get x plus 5 equals plus or minus the square root of 28. So it's like what we did with solving root in 5.3. We can subtract 5 on both sides to get x equals negative 5, because remember that goes out in front, plus or minus square root 28. And I can simplify that into root 4 and root 7, because 4 times 7 is 28, and root 4 becomes 2. So I end up with negative 5 plus or minus 2 root 7. So by completing the squares, I can factor now by finding the roots. So now doing this, you can't complete the squares unless all you have in the front is an x squared. So what I need to do now is I need to see if I can factor out that 3 to get rid of it. And surprisingly enough, I can. So I end up taking out a 3 from everything, and I end up getting an x squared, a negative 2, and a 4. So can you think of two numbers that multiply together to give me 4 that add to give me 2? No. So I have to use completing the squares to solve that in the middle. So what you realize is if I really wanted to solve this, that 3, I got to divide both sides by that 3 to get rid of it. And 0 divided by 3 is just 0. So really this is all that I'm left with. So I can't factor it. So the b over 2 squared, well, it's a negative 2. But before we do that, let's get the x's all by themselves on one side. So I end up with x squared minus 2x. I left a little space in there, and I have negative 4 because I wanted to get all the x's on one side by themselves. So now when I'm going to do this, b over 2 squared, my b is a negative 2. So negative 2 divided by 2 is negative 1 squared, and negative 1 squared is 1. What that means is I need to add a 1 to both sides. And when I combine that, I get x squared minus 2x plus 1 equals negative 3 because negative 4 plus 1 is negative 3. This negative 1, that is my factor. So all of this side factors into x minus 1 because it's negative. That's the factor. So it's x minus 1 squared equals negative 3. I square root both sides. So when I do that, this negative I pull out because you can have a negative underneath the square root. But let's just get x by itself first, right? So I add 1 to both sides to get that over there. And this negative needs to now come on the outside, which becomes an I. Remember the i's when we did 5.4 there. So that becomes an I root 3. We still have a plus or minus and a 1 out in front.
Is your final answer?
When we come back here, I will finish up 5.5 on completing the squares.